So now that you know a bit about how variables work in RAM, and you understood how theoretically we could take care and access our variables not through their names, as we did so far, but rather by accessing the memory location directly with the variable's address, let's see how this can help us get around the limitations of variable scope. First, here is an integer x to which I give the number 0. Now, any variable that you create, whether it's a built-in basic type or even an instance of a custom class which you yourself invented, if you want to see the memory location, the memory address where this variable is stored in memory, you can get that easily by using the ampersand symbol right before the variable's name. For example, if I want to print out the address in memory where my variable x is currently located, I would print out not just the variable x by itself, but rather the address in memory at where this variable is located. And this is done by using the address operator, which is the ampersand symbol right before the variable name. And that will cause that instead of the variable name expressing the value which is inside of the variable, instead we get an expression of the address, the numbered memory location at where this variable is located in RAM. Now, just to clarify, of course, when you create a integer variable in your program and it takes up a certain amount of bytes, if, for example, your integer takes up 4 bytes of memory, then apparently you'll have 4 different memory locations, 4 different memory addresses, 1 address for each byte. But since it's only one variable which happens to take up 4 different bytes, then the only important address which we want to know is just the very first address of the very first byte. So we behave as if we just have one big cubbyhole which measures 4 bytes and it only has one memory address, which is the very first one. We don't care about the second, third, and fourth memory address because all we need is the very first address of the very first byte. So basically what I mean is that a variable only has one and only address, which is the address of the very first byte of the variable's memory. So you shouldn't think that a variable has 4 addresses if it has 4 bytes. No, that's not true. A variable, whatever size it may be, even if it's hundreds of bytes long, it only has one single address, which is the address of the very first byte of that object. So back in our code over here, when I use the ampersand and then the name of my variable, what that does is it's an expression giving me the actual memory address of the very first byte of my integer variable. Okay, so now that we know how to get the address of a certain variable, how do we use that address to help us around the limits of scope? Well, for that we have to learn a new type of sort of variable in C++ called a pointer. A pointer is a type of variable which isn't made to hold real useful regular stuff like a number, a score, a name, a letter, or something like that. A pointer is made to hold precisely memory addresses inside of RAM. That's what pointers are designed for. So you'll never use a pointer to store a number or something. You'll use an integer variable for that. But whenever you need to play around with addresses of variables, you'll be using a pointer. Now, when you create a pointer, you must specify exactly what type of variable or class this pointer will be pointing to the address of that type. Because when you make a pointer isn't just a plain old object which can be applied to any type of variable, whether it's an integer or a char or something else. No, a pointer can only point to the address of one specific type, and you must specify what that type will be when you create the pointer. Here is how a pointer is created. Let's say I want to make a pointer which will point to the address of x, our integer. So I will declare that my pointer will be pointing to integer. Then I use the asterisk, the star symbol, which means that I'm not creating just a regular integer variable, I am making a pointer which points to an integer type, and then I will give my pointer a name. Let's call it PTR. So it looks very much like creating a regular variable, just like I create int x, I create int PTR, just that I add the asterisk in between, which means that this is a pointer, not a variable. As we will see, a pointer is very much like a variable. It has a specific type, it has a name. It is also pretty much like a box which contains something inside of it, just that one of the differences is that a regular variable holds some useful information like a number or a letter or a word, while a pointer will only contain addresses in memory. So now that we have our pointer, let's make it point to the address of our x variable, which is done simply by using the assignment operator to assign the address of our variable x to our pointer. And there we go. Very much like assigning 0 to our variable x, we assign the address of x to our pointer, which is of type integer. So this is what's going on. We have an integer variable over here. The name of the integer variable is x. The contents of the integer variable is 0. The address, the memory address where our variable x is located, is whatever this number may be. We can only find that out when the program is running. Over here, we are creating a pointer. The pointer's name is PTR. The type of stuff that this pointer will point to is only integer variables. The contents of PTR at this moment is the address of wherever x is located in memory. Let's print out all of this information to the screen. Okay, let's check this out. First, we're going to print out integer x's address. And for that, of course, we print out the address of x. Next, we print out integer x's contents. And to get the contents of x, we just print out x itself, as we learned. Now let's move on. Integer pointer PTR's address, don't get confused over here. Just like integer x is some sort of stuff in memory which has an address, PTR also is stuff in memory which also has an address itself. So besides for the fact that PTR, that pointers in general, will always contain addresses of other variables, pointers themselves also, of course, have a memory address where they are located in memory. So just like our integer x over here is using up 4 bytes of memory and therefore it has an address of where in memory this is located, our pointer down here also uses up a couple of bytes in memory. Actually, on my compiler it uses up also 4 bytes of memory, and so those 4 bytes of memory also have a memory address. So don't confuse the memory location at where a pointer is stored and the memory address which the pointer contains inside of it. And that's the two different stuff which we are printing out over here. First, we are printing out the pointer's address, which means where in the world is this pointer located in memory, and then afterwards we are printing what is inside of that memory location. What do we have in those 4 bytes of memory? And we print out the pointer's name. Let's see how this works. First, we print integer x's address. Right over here we gave the address, the ampersand symbol, and so we get the memory address, which of course looks funny, 0022FA94, whatever. Next, we print out what is inside that memory location, what is inside the variable. And of course, we gave our variable x the number 0, and so that's what we see. Next, we have a look at where in memory is our pointer located, just like we wanted to see where in memory is our x located. As you see, it's a different place than our variable x. Our variable x is at 22FA94, and the pointer is somewhere else. It's located at 22F888. Finally, we have a look at what is inside the pointer, what is the contents, what is inside of that memory location, and we see 0022FA94, which is exactly the address of our variable x. So as you can see, the contents of this variable, this pointer, the stuff that it's holding inside, is an address of some other variable.